Okay, this is section 5.1, and today we're starting a chapter all about triangles and kind of what happens inside of a triangle. And this first day we're going to talk about a couple of vocab words, mid-segments, and then mid-segment theorem. And we're going to be able to use these and properties of mid-segments to use coordinate geometry to prove properties about figures. And again, mainly we're going to focus on triangles. So a mid-segment of a triangle is a segment that connects the midpoints of two sides. So looking over at this picture, these two tick marks mean that M is the middle or the midpoint. Same thing happening over here. I've got these two tick marks, which means that P is the middle. So if I connect two midpoints, I create what is called a midsegment. And there are three of them on a triangle. There would be this one and also this one. So there are three mid-segments. Now what happens with a mid-segment, once you kind of draw them or once you figure them out, they do two different things. A mid-segment, each mid-segment is parallel and half as long as the third side. Or I'll kind of say like the side they don't touch. So if I look at this midsegment, DE, this guy right here, it is both parallel to the side it doesn't touch, so this one, and it's half as long. So DE is half as long as AC. Okay, so AC is twice as big as DE. I could fit two DEs right here. And we're going to use those properties in order to solve problems today in your homework. So the first one says, in the diagram, J, K, and L are midpoints. So that means this is the middle, this guy is the middle, and this guy is the middle. Let's zoom in a little bit so you can see that better. If DE is 8x plus 12, so DE is right here, 8x plus 12, and KL, which is right here, is 10x minus 9. What is DE? Find the length of DE. So we know that KL is a mid-segment. I'm kind of darkening these in. And so we know that it is both parallel to this side and half as long as this side. So you can do one of two things. You can either times this guy by 2, because if you look at the picture, it would take 2 of these to make all of DE. So I'm going to do 2 times 10x minus 9 equals 8x plus 12. Your other option, and I think it just creates a little bit more confusion for kids, is to take this, 10x minus 9, and set it equal to half of 8x plus 12. And most kids prefer this option because they find it easier to distribute a 2 than they do to distribute a 1/2. Right now it's not too tricky because these are both even numbers, but when it becomes like a 5 or a 3 or if it's an odd number, then that dividing by half, it tends to mess kids up with the fractions. But you pick whichever way you want to go, and then we're just going to solve for x. So I'm going to distribute this one and get 20x minus 18 equals 8x plus 12. I'm going to move the 18 over and end up with 30 minus 8x. So I get 12x over here equals 30. And then I'm going to divide. I'm going to get a fraction, get a little, get a decimal here for 30 over 12. And we're at 2.5. They wanted me to find the length of DE, which means I need to plug this back in. So I'm going to put a 2.5 right there. And 2.5 times 8 plus 12 gives me DE is 32. The next one says the midpoints of 3 sides of a triangle are given. Find the perimeter of PQR. And then find the perimeter of the original triangle. So there's a triangle out there. Let's give these some letters. Let's just go ABC. And the midpoints are P, Q, and R. So those are my 3 mid-segments. And they want me to find the perimeter of PQR, so all the way around, which means I need to do 3 distance formulas. We're going to have to do PQ, QR, and PR. I need the distance of all of them. And then they want me to find the perimeter of the original, the big triangle. What's handy about mid-segments is since they are exactly half of their opposite side, once I find out the perimeter of the little guy, I just have to double it. So let's do the distance formula 3 times and see what we get. PQ, starting with that one. So P and Q, I'm going to do x minus x, 7 minus 2, and 12 minus 0. And here I'll get 5 squared, which is 25. I'm going to try and sneak this in. And then 12 squared, which is 144. Sorry, I'm going to come down here. 144 plus 25 gives me a square root of 169, which is actually, my brain farting, 13. Sorry, we really had to squeeze that in there. I'm going to have to move this guy down here so we have room. Q, R is the next one, so from Q to R. So I'm going to do 16 minus 7, and then 0 minus 12. 16 minus 7 is 9 squared, so 81. And negative 12 squared is 144. And 144 plus 81 gives me 225. And the square root of 225 is 15. Last one, PR. So from here to here. So I'm going to do 16 minus 2 squared. And then 0 minus 0 squared. 16 minus 2 is 14 squared, which is 196. So that side is 14. So I've got a 13, a 15, and a 14. I'm going to add those together. Those are my 3 sides of the triangle, and I was supposed to find perimeter, which means all the way around. So adding up the 3 side lengths, I get 42. That's my mid-segments, and I want to find the perimeter of the big triangle, so I'm just going to times that by 2. So I'm going to get 84. It doesn't say inches or anything, so we'll just say units. That's the perimeter of the original triangle. So your big job today is mid-segment, which is joining 2 midpoints together in a triangle, and it creates a side that is both parallel to the third side and then half as long as the third side. And then working with that property in order to solve different problems.